All right, let's get started on our section 1.1.1 study guide. I'm using Kami as the PDF writer. You can use any kind of PDF writer or write this in your math notebook, or you can print it and handwrite it. Here we go. I'm going to start with the insert text box function. A function is a special kind of relation in which each value of the independent variable is paired with exactly one value of the dependent variable. Now, if these words are new for you, dependent variable and independent variable, I'm just going to go off to the side here and put a little side note that you might know the independent variable as the x value or the input, and you might know the dependent variable as the y value or the output instead. So if we're more familiar with these, I'm going to put these words over here to the side to give myself a reminder of what these are. I'm also going to go up to the top here and give myself a quick definition of relation. A pairing of one set of info with another set of info. This definition came from the lesson study within Apex. Remember that you can pause the video at any time if you need more time on one section. Okay, now it's going to go into some specific examples like tables, like mapping diagrams, like functions, etc. And it's going to ask us whether it's a function or not. So here's our first one. It's given to us in table format. Pedro is shopping for clothes online. When he puts in a price, the website displays the products that cost that much. The table below summarizes what he's found. When he inputs 25, it says tie, 30, it says belt, 40, it says jeans, and oh wait, 40 says shirt as well, and that's our hint right there that something's going on. So I'm going to say, no, this is not a function, because the definition of function is that for every one input, there's only one output. But up here at the 40, there's jeans, and at the 40, there's shirt. Both of those outputs can't go with the same input for it to be a function. So we're going to go ahead and say, no, this is not a function because for each input, there are sometimes more than one output. Or you could say for the independent variable $40, there are outputs of jeans and shirt. Or maybe you could say also for the input of $55, there are 3 outputs. Notice that your words are going to vary compared to my teacher answer key. So you can put this in your own words as long as you're saying, no, it's not a function, and your reasoning makes sense with the diagram. All right, on this next one, we're looking at a mapping diagram. And that's these little lists of numbers. Here's our X values, here's our Y values, and the lines that are drawn in between are telling us what outputs go with every input. So here's my X's, here's my Y's, here's my domain, here's my range. So let's check this out. This letter 3, for example, goes to 15, the 6 goes here, 12 goes here. Those are coordinate pairs, and there's only one line coming out of each input. So for this answer, for this one, on this mapping diagram, I can say, yes, it is a function, because for each input, there is only one output. There is only one line coming out of each independent variable. Well, look at the next picture. In the next picture, this 7 is paired with both the 10 and the 23. If I were to write out this coordinate pair, there's a coordinate pair of 7, 10, and there's a coordinate pair of 7, 23. So we're finding that there is a repeated x here, and that there's 2 lines coming out of this input, and there's 2 lines coming out of this input. So when I answer this one, is it a function, yes or no? Because the input of 7 has 2 outputs. Also, the input of 30 has 2 outputs, or 2 lines coming out. Now we're going to go to some fill in the blanks here. So if n equals p of m, blank is the function name and blank is the independent variable and blank is the dependent variable. So if I go over here for a second and just talk about what we're used to, which is something like y equals f of x, y is the output, x here in the middle is our input, and the function name is f of x. So now let's look at these different letters. So that would mean that p of m is the function name, and that would mean that m is the independent variable. Remember that the independent variable is your x value or input. Getting used to this new vocabulary. And that would mean that n is your dependent variable or your y value or output. Suppose you are given the function f of x equals 7x and asked for f of negative 6. This is the same as asking for the value at x equals negative 6. X being the input inside the parentheses. Suppose you're given this function and asked for g of 8. This is the same as asking for the value of the function at x equals 8. Finally, suppose you're given this function and asked for h of 4. It's the same as asking for the value at x equals 4. Now that they've gone over what it's asking for, they want us to show 3 examples of us truly plugging in an input. Here we're being asked to put in a negative 2 for every place that there's an x. Here we're being asked to plug in a 1 in place of every x and plug in a 3 in place of every x. I need to actually show work on this one, so I'm going to go to the equation, and here we go. So for the first one, letter A, f of negative 2 equals, plug it in, 10 parentheses, negative 2 minus 1. Now, if I notice where I placed this equation, I didn't really give myself a lot of space. So I'm just going to drag it over to make sure I have some space below it. Next step, f of negative 2 equals, and we're going to simplify a little bit. First, using PEMDAS, I'm going to multiply. 10 times negative 2 is negative 20 minus 1. And then final step, f of negative 2 equals negative 21. And that's my answer that I'm going to place here on the line. When I go to show my work for the next one, I'm going to choose a different color so it stands out apart from these. For my g of negative 1, I'm going to use red. G of 1 is equal to negative 5 times 1, plugging in the 1 for x, plus 13. Notice I'm using parentheses to plug in. G of 1 equals negative 5, doing PEMDAS, multiply first, plus 13. Final answer, G of 1 equals 8. Notice that I'm matching my answer in red so that I can see which work goes with it. Finally, I'm going to do h of 3, but I'm going to use let's go green. When I do a plugin for 3 squared, I'm going to use the Shift 6, which gives me that little up arrow, and that gives me a power of 2, minus 3, minus 12. Nine minus 3 minus 12. So if I do the negative 3 minus 12 first and get negative 15 plus 9, my answer is going to be negative 6. So see all my work shown on these equations? This is from Math 1 evaluating functions. In the function n equals p of m, go back to my text box, domain is all possible values of m, and the range is all possible values of n. The table below shows a dog's age at various points throughout his life in both human years. Which is the independent variable and which is the dependent variable? So what is the domain of this function? Because this is a table, the x values and the y values need to be listed out separately for the domain and range. Because we don't know what's going on in between these values, we only have these inputs and these outputs that are given to us in the form of a table. So as a general rule, when given a table, the x values and y values need to be listed out separately for domain and range. So when they ask me for the domain of this function, I'm going to give it in a list from least to greatest. So I'm going to say 1, 2, all the way to the end. Remember that we don't need to list any repeats. Here there are no repeats. We're good. Next, what is the range of this function? Again, we're going to list this out, least to greatest order, which it happens to already be in that list, and one by one. Write the domain of each of the following functions in interval notation. So on these ones, we are looking at two kinds of functions that you've never been exposed to before, but these have some kinds of restrictions just based on the general idea you may have. For example, you cannot have a 0 in the denominator, or it is undefined. So if you can't have a 0 in this denominator, let's talk about what values would not be allowed here. If I did 13 minus something that gave me 0, then that wouldn't work. So I want to say something in interval notation along the lines of all values or all real numbers except x cannot equal 13. Because if 13 minus 13 gives us 0, that would be undefined. So how would I write the interval notation of that? I'm going to say something like this. And by the way, I'm going to go into the equation. And so we're going to say that we want to say that it goes from negative infinity up to 13, not included, and then from 13 to infinity. So notice if I click here, I have options for infinities, etc. All right, so I'm going to say from negative infinity to 13, not included, U for union, meaning and, from 13 to infinity. Open brackets on everything because the 13 is not included and because infinity always has that. All right, so now the next function is when g of x is equal to square root of 9 plus x. Remember, I cannot have, do a text box here. You cannot have a negative under the square root. So what number would make this turn into a negative? If I did 9 plus negative 9, that would give me 0. That's still okay. If I did 9 plus negative 10, that would not be allowed. So this needs to be all numbers greater than or equal to negative 9. So in words, it's all real numbers greater than or equal to negative 9 would be okay, but we need to write this in interval notation. So I'm going to go to the equation. I'm going to say from negative infinity, no, I'm sorry, all real numbers greater than or equal to negative 9. So I'm going to say close bracket negative 9 to infinity. Notice the negative 9 is included because it's okay if this is equal to negative 9. Square root of 0 is just 0, but everything after that would not be allowed going left on the number line. So here's my interval notation. Here's what the words are that go with it. Next function, this bottom section also cannot be equal to 0. So if we're looking at a fraction this time, and if it's easier for you to see us set it equal to 0, so if we go 2x plus 1 equal to 0, let's solve and figure out which value would not be okay. So 2x, first of all, if I subtract 1 from both sides, and then we divide both sides by 2, we're going to be left with x equal to negative 1/2. So now I cannot have x equal to negative 1/2. I want all the rest of the numbers, all real numbers, except x equals negative 1/2. So how do I say that in interval notation? I'm going to go into my equation. and say negative infinity up to negative 1/2. U for union, 1/2 also not included since it can't be equal to that, to infinity. Finally, right here, I want to make sure this doesn't go into a negative square root. So what numbers could we plug in here that would turn into a negative? First of all, if this was 3 minus 3, that gives us 0, so that's okay. But if this becomes -1, for example, that turns this into a negative. If I plug in 0 here, that's 0 minus 3, that's also a negative. So there's lots of possible values here that are not going to work. So your job is to figure out what that value is that's not going to work, and then we want all real numbers except that greater than or equal to that number. So let's check this out. If I add 3 to both sides, and divide by 4, so I'm going to say from 3/4 to infinity. Write the range of each of the following functions in interval notation. So if you took this function and you went over to desmos.com and typed in the x squared minus 7. So we're typing in x squared minus 7. We haven't been exposed to these graphs yet, so let's go take a quick peek on what this is going to look like. So check out this graph. X squared minus 7 is going to be a parabola. This is a new function we'll be exposed to this year that begins at -7 and goes up from there. So the range will begin at the least of -7 and go to infinity. So range and interval notation for this one goes included -7 to infinity. Finally, the square root of x plus 5. Let's go put in that graph into Desmos and see what that looks like. What's the range of this one? It's beginning at 5 and going up from there. So my interval notation on this one begins at 5 to infinity. So notice in both these cases, for both these ranges, that this y-intercept, this constant at the end, turned out to be the value we used for the beginning of the range in both these cases. All right, I'm not going to require you to do number C or D on this. It would come out to be the same thing with those little y-intercepts, but just for time purposes, page 18, what is the domain and interval notation of this function below? Note that as x is approaching -2, it's getting closer and closer but not touching. So my domain farthest left is going to go from -2 to infinity on the right. So I'm going to say not included because it's approaching but not touching, -2 to infinity. And that's it. That's my domain. What's the range and interval notation on this function? Notice that the highest it goes to is here, but it goes forever down. So I'm going to say that it goes from negative infinity to all the way up, 1, 2, 3. It stops at positive 3. The 3 is a closed bracket included. Given an example of a function with a domain that goes from negative infinity to 0, so something that goes from negative infinity to 0 stops right here and goes forever in that direction. Give an example of a function with a range from 4 to infinity. So let's say we begin at 4, and then we draw a parabola that goes forever up, something like that. And that's it.